All right, well, thank you. I'm really excited to be giving this presentation today. It's a lot of fun and looking for some engagement. So absolutely, if you want to use the chat module in the upper right of your dashboard, you see a little question or chat bubble that you can click on that kind of near where everybody's name is. Anyway, let's get into this. As you can tell, this presentation is going to be really subtle and not very opinionated. Now, we're going to be pretty straight to the point. We want to get rid of manual deployments before they cause us harm. Right? I do not like these things. So just one classic example where things went wrong. One of the contributing factors to Knight Capital losing $440 million over the course of 45 minutes in 2012 was kind of a failure to sufficiently deploy new code correctly. Right? Real economic harm from getting this wrong from an error point of view, let alone inability to go agile because we're too slow and things like that. Manual deployments are dangerous things, and I want to get rid of them. So that is my thesis. Now, who am I? My name is Eric Minnick. Joined IBM about 1.5 years ago with the acquisition of UrbanCode, and I've really spent the last 10 years or so focused on build, deploy, release, continuous integration, continuous delivery, DevOps. It's kind of been my world. Co-author of Application Release and Deployment for Dummies, yeah, I present on the topic a lot. So this is kind of my background. I spend a lot of time working closely with customers, helping them with their processes. And my bias here is that I really don't like these manual deployments. I am not going to be nice to them today. They're slow. They're inconsistent. The inconsistency means we fail in production. And our traceability is not so good, right? Our visibility into what happened tends to be spreadsheet-oriented, tends to be what people think they did. Now, there are some people who will come and defend manual deployments, right? And surprisingly, it's often the people who are running the deployments themselves. Right? They feel like they're in more control. They've been doing this a while, and they're good at it. And they can see what's happening right in front of them and react to it. And saving the day always feels good. Who doesn't tend to feel good about this is everybody else who's one step removed from these engineers and don't kind of have that feeling of control. And don't like being dependent on somebody else to do everything just right or react or have an act of heroism. And the other people who don't like it are these engineers when the rate of deployment starts going up, when the production releases over the weekend go from being every couple of months to most weeks. Right? When they stop seeing their families, they're a little less in love with this approach. So I figured I'd give them their due. The in-between option here are scripts. Right? If I've got some scripts that help me with my deployment, is it automated? Am I there yet? Am I done? The questions I always ask are on this slide, like how many do you have? Do you have to run them in a certain order? How do you version these things? How do you get them to the right box? Are they consistent? So if I'm in a situation where in order to run my manual, or in order to run a deployment, I need to move scripts out to 10 servers, I need to go to each server, log in, and run 3 different scripts in the correct order, passing in a bunch of parameters, I've got a lot of opportunities to get things wrong because I have a lot of manual steps. And so you're partway there. You're better off running 3 scripts than working through a 30-page Word document telling you what to do and having 50 actions that you take rather than 3. But it's only a partial solution. So that's my take on scripts. So get that out of the way. And now just to kind of wrap up this little introductory section, I'm a fan of automated deployments, and I'm a fan of the automated deployment where you press a button and the deployment of the application happens. For all the reasons that I hate manual ones, right? They're fast, consistent, and they work in production, right? Nice and auditable. So adding on to this, we have a platform that we can create from our from our automated deployments. They can let us do more things than just deploy stuff. And I think they're really good for people, right? They let people focus on what people are good at, right, and get their work done. And I think they let us break the classic iron triangle. The classic iron triangle, right, is that you can have quality, speed, and cost, and you can optimize two of those things at the expense of the third. Right? And you can imagine in a manual world of doing deployments, if I want to be able to do more deployments than I can handle right now, I could hire a lot of people. And maybe I could hire another batch of people to check the work carefully. And that would allow me to be faster and allow me to have better quality, but it would be expensive. When we do a paradigm shift, right, we can break the iron triangle and get all three. And I don't know about you guys, but I like all three of those, and so I think this is a win. All right, so here's what we're going to talk about today. We're going to talk about manual deployments and why they're terrible. Then we're going to talk about what we've learned from that and what that then requires from an automated solution. So we'll kind of design a solution together. And then finally, we'll talk about how we can exploit that to do more cool stuff, right? Take advantage of the fact that it's a platform to build on. So let's start with today's manual deployments and why they're awful. In here, I'm going to, with apologies to Jeff Foxworthy, you might have a manual deployment if. So you might have a manual deployment if handoffs between groups are done through email, right? If you email somebody and say, here is something to deploy, please deploy to QA, and then you wait for them to email you and say, it's been deployed to QA, you've got a process that's slow. You got to wait for the other person. The deployment person is probably different in different environments, and so you have inconsistencies inherently. And those inconsistencies mean that you haven't tested your deployment process before you go to production. And so you're probably going to have risk of failure out there. And your audit trail very often is email chains, right? Pretty much stinks. So not a good situation. Now you might also have a manual deployment if dev, QA, and ops do things differently. So maybe they've all set up their own scripts, right? Maybe ops is using a infrastructure automation tool, development is using their build system, and QA is doing it completely manually, right? Then we're going to be left with these awkward handoffs. We're going to be left with inconsistency, and again, that'll lead to failure. Now we might also have a manual deployment if tweaks that we make are communicated on an as-broken basis. So this is one of the things, one of the patterns in IT that drives me nuts. And I know you guys have all seen this, right? Where, a developer makes a change to the code, and that requires a change to the infrastructure, maybe a middleware setting like this data source I mentioned. Right? They do that on their dev environment, things work, they say, oh, let's promote the code up to QA, it blows up in QA, and then after everybody yelling at each other and it works in my environment, what's wrong with you, the developer sheepishly says, oh, right, I forgot to tell you. This is data source you need to add. There's this configuration change we need to make. And then everything works in QA for a few weeks, and we move off to performance testing, and it fails in performance testing. Same problem eventually. After yelling at each other, we figure it out. Then we go to production, and hopefully by the time we go to production, someone will have written this down as something we need to do when we release the code. And very often they'll have done that successfully, and things will be fine in production. And sometimes they won't, and you'll have a failure, and it'll be a very bad night for everybody. All right, so if you've got this as broken communication pattern, the problem is not a lack of discipline. Your systems are not supporting you to make this better. If there's a deployment document, if that's big, you might have a manual deployment. Just might. Right? I've seen the 50-page Word docs. I've seen the Excel spreadsheets for an enterprise release that have had thousands of lines in them. Yes, that's literally thousands. If there's a big old document or wiki page or something like that that tells you how to run a deployment, you've got trouble. Because I guarantee you that developers are not reading that carefully when they're making changes in dev test. You've got that inconsistency. There's probably things in that guide or document that should not be done every time, and experts know to skip over them, and a new person will do and cause trouble. Right? So you've got a very risky thing in this document, very hard thing to maintain. And we might also have a manual deployment if we talk about the deployment weekend or deployment nights and things like that. We know that you have a slow, risky process if you're trying to mitigate that risk by running your deployments in the middle of the night. Right? If you had a process that always worked and you had a zero downtime deployment and it was fast and you could roll back trivially, you would deploy in the middle of the day on a Wednesday rather than in the middle of the night or over the weekend. If you talk about whole weekends, then we know the processes are really slow. So think about when you do your production releases and what that implies for everything else. Right? If you're really trying to do deployments to test environments overnight, that's also indicating that there might be an issue, right, in how we go to test. And I'm going to flip it this time. If you do manual deployments, developers probably have production passwords. Now, I'm looking at the list of people here, and I'm guessing almost everybody on the call right now is saying, oh, no, 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 no. We're regulated, Eric. Developers do not have production passwords in my environment. And at least that's true if you're in release management, release engineering, if you're on the opposite side of the house. If you're a developer, and you're sitting there with a production password in your head or in your notebook, you're kind of sheepishly going, yeah, that's kind of true. So here's why developers have production passwords when you have manual deployments. We've already established that manual deployments are inconsistent and fail in production. And sometimes we have these tweaks that are communicated as broken. So what happens is it's 3 a.m. on a Saturday night. Everyone's in a panic. We're about to blow our outage window after our deployment has gone wrong. And we can't figure out how to fix this thing. So we call up the on-call senior developers. We bring them in. And at some point they need to see a log or look at how something's configured, and they're given a password. Right? And then they fix it. And now it's 5 in the morning, everyone is dead tired, super happy to finally be done, and they go to sleep. And we all forget to change the password when that's done. And now the developer occasionally uses this password to look up logs. If they were an evil person, they would do terrible sabotage. Most of the time they're not, though. But way more developers have production passwords than should, and it's a very, very common pattern when you get people off the record. All right. So with that, I want to step back because I know there's managers who say, okay, look, what we really need here is discipline. Our deployment docs can absolutely work. We just need to update them and follow the instructions. We've got audit spreadsheets. We just need to fill them out right. I have hired grown-ups to work in my company. They should be able to do this. I think that sounds on the surface to be a reasonable objection. The problem is that people are not machines. We are really, really bad at being consistent. We're bad at remembering to update documents. We're terrible at reading instructions, comprehending them, and doing exactly what they say. Right? I think there's a Jim Highsmith quote saying something to the effect that people can do similar things over and over again, but never exactly the same thing. Right? You know, if you asked me to tie my shoes 1,000 times in a row, I'd probably mess it up once. And yet we look at how we release these pieces of software that are fundamental to how our businesses compete, and we get engineers in a high-stress environment. We have them working in the middle of the night when they're tired, and we expect them to run many, many kind of discrete steps absolutely correctly. We are setting ourselves up for failure in a very predictable way, right? People are creative. They want to help the business win. They're good problem solvers. They are bad at being robots. Machines, on the other hand, are terrible problem solvers, but they're really good at following instructions. What we want to do is find the non-creative work, the following instructions part, give that to machines who are good at it, and then leave the creative work and the problem solving over to people. That's the goal, right? And I would recommend the paper I've cited down at the bottom by Alistair Coburn, characterizing people as nonlinear first-order components in software development. One, that's a hilarious title. But two, that's free on his website. Is a really good read talking about what people are good at and bad at and how that impacts delivery of software. All right. So I hope at this point we've established that manual deployments are pretty terrible and why they're pretty terrible. Let's look at what we need from automation, right? So we need this stuff, so I'm going to go through kind of another 6 slides here talking about the elements. We need an automated process, right? We need one button that we press, and the application goes to the environment. Right? Very simple conceptually. We need this to be consistent across environments. We need it to be run quickly, and it should be good and repeatable. We want to get away from, you know, there's this Word doc and I interpret the Word doc. I want to say, well, there's code, and the code runs and it does the thing. That's the fundamental goal, right? Obvious. We need to coordinate across tiers or components. Our applications today are not small, discrete things that can be deployed independently. They're distributed systems. Kind of favorite definition of a distributed system I heard recently was a distributed system is one in which the failure of a server you've never heard of can bring down your application. Right, we've got multiple tiers, we have web services, we have multiple front ends. And when we're doing our testing, we're testing across all of these components and tiers, right? At least our late functional testing. And since that is what we are certifying works, that's what we want to deploy in a coordinated fashion across the environments. A lot of the configuration we're dealing with spans this. So we need to model the whole system, standard deployment model for how would I deploy everything, and then we want at runtime to deploy only the stuff that changed relative to the environment so that we don't spend more time and introduce more risk. Then we've got snapshots, and I did have an animated slide in this presentation and I missed it. But basically, apologize. Instead of treating all of the little blocks here, each of those components of this distributed system, as discrete deployables. We want to create a logical version of the whole system that says, well, it's a bill of materials, right? Version 1 of this web service goes with version 2 of that web service, goes with databases, changes Q through Z, etc. And then we need to account for our environments. All right. So if we're going to have a standard way of deploying our application, we're going to want to have a step in there that says, now bind the business logic to the backend database. Oh, by the way, here's the database password. Here's the database connection string. All right, that'll be part of our overall process. But you're very, very, very likely to have different passwords in production than you do in dev test. This undermines the goal of having consistency. And so we do a little bit of a refactor, and we say, well, I'm going to model my environment as a formal thing. I'm going to model my deployment process as something that takes the environment as an input. The environment will provide a lot of key information to us, such as the database credentials, what servers we're deploying to, how many servers there are. And our deployment process will adapt itself to the environment we're deploying to. Right? So we want to get away from property files that live on the server that aren't really versioned anywhere. We want to get away from, this kind of switch or extra instructions in our Word doc that say, and when you're in this environment, use this password. And when you're in production, well, hopefully you've got it memorized. Right? We don't need anybody to know the password. The password can just sit in the system. Cool. All right. And we need an authoritative place to get the stuff to deploy. So we ran a survey, it's probably 2 years ago now, and we said, hey, when you're deploying, say, to production, where do you get the files? Right? Where do those come from? And we did let people select multiple options here if they had a couple of different places things came from. So maybe, builds would come from the build server and database changes would be pulled straight from source control. So the percentages add up to over 100%. And I think they add up to over 200%, so the average person had at least 2. But we had, 7.5% of people admitted that they just email the files around, which is kind of sad. Only 22% had a formal artifact repository, an official storage place that was optimized for binary files. Almost 60% are using source control systems, which are optimized for manipulating small text files to hold their outputs. Right? And it's at least a versioned thing, right? So that's progress. About a third just store stuff out on file shares, right? Very uncontrolled, right? Someone else could go to the file share, go into the directory for build 1.2.3, put whatever the heck they wanted. Your traceability is real weak if you're out on a file share. Similarly, we had 16% just go to the previous deployment environment and pick up the files that were there and move them forward. That's got the merit of at least trying to deploy what we've tested. The problem is that often your permissions in the lower environments are not quite secure. So senior developers, maybe senior testers can log on to the box and poke around. They might also be able to manipulate your deployable artifacts and put whatever the heck they want in there. That's a problem. And then 40% are using the build server. Very reasonable. Build server is often kind of a quasi-repo in them. So this is kind of all over the place. The big thing that you want is this single source of truth. I want to have a place where the bits that can be deployed to any environment live, and they're version controlled there. It's secure. They can't be manipulated. These are things I can trust. In ITIL, this is called your definitive media library, or your definitive software library. Right? There's this kind of the formal concept. But you need something to play this role. And then we need access control, right? We've talked about a consistent tool set for deploying from dev test to production. We do want to allow developers to deploy to dev test in self-service so that they don't have to email someone and request it to be run, because we already established that that stinks. Instead, we want to give them a button they can press. Great. But we also don't want, new hire junior developer to deploy something else to production, right? They don't have that knowledge of what should happen. If we're a regulated company, we're probably failing separation of duties concerns, so that's an issue. So we want to get away from the idea that we're going to control security by who can log into a machine and move to role-based access control. This is a release engineer, they can deploy to production. This person is new hire junior developer. They can deploy their little application to dev test, and that's it. And there's other people who can deploy places in the middle, right? And we'll bind that out to sources of truth. Cool. And then we're going to need an audit trail. I like talking in terms of winning at clue. You need to know who did it, what did they do it with, how did they do it, where did it happen, all of that, right? We need to know Bob ran the deployment of version 1.2.3 of this thing to production, passing in this value of this parameter. And when I said ran the deployment, that was version 7 of the deployment process. We want to have all of that there. And then when we say, well, there's version 7 of the deployment process, we want to know how that differs from version 6 of the deployment process, who changed it, and what are the before and after values. All right. We need to know how this all happens. And we don't want to rely on any people to write down what they did, because people are bad at being consistent and remembering what they did. All right. So we're talking about an automated system. It should write down what it's doing. It should record logs and deployments. It should have a good audit trail. It should not be that hard for software. All right. So if we've got this kind of a stack, right, if we've got a button that we can press, and role-based access control, and audit, and artifact repository, and environment modeling, fundamentally, our deployments to production are going to work, and that's the main benefit here, or at least the top line. But we're also going to see a lot of speed come out. Our QA teams are going to be able to take new builds faster. Development is going to be able to make a code change and then see it live running in a test environment moments later. We're going to have solid audit trail that doesn't begin at production but goes all the way back to dev test. We're still going to have our separation of duties. This is very good, right? This is what we're looking for. And I think the speed element is core. Within the customers of UrbanCode Deploy, something like 82% that we surveyed noted faster time to market as a benefit of adopting the deployment automation. And that, I think, comes from being free to deploy to production more often because there's higher confidence and less risk, and more efficient development test lower on down the chain. Cool. So let's say that we've established that we should probably do our deployments in an automated fashion. How do we build on that? And that's going to be the last third of this presentation. So again, about 6 things. that I'm going to go through real quick, starting with deferred deployments. So maybe I do want to deploy Friday night, but I also want a life. So I just go into my tool and say, hey, deploy to my test environment at 11 o'clock on Friday. I'm going to be home with my family. In my youth, I might have been out with my friends. Either way, I'm not at work. And if there's a problem, my cell phone will ring. Cool. There's not going to be a problem. We just schedule deployments to run later. We also can have self-service, so we can let our developers and testers just press the button whenever they want and get a version out there. One of the classic examples that I ran into years ago was an offshore QA team. Periodically, they'd come in the morning, and the latest drop from the U.S. development team would be so broken as to basically be untestable, and their productivity for the day approached zero pretty quickly, despite their best efforts. They'd have to wait till the next day. So what they ended up setting up is they still don't want the offshore contract QA team to log onto the boxes, but they gave them the button that they could press to say, yeah, give me yesterday's build. Redeploy what we had yesterday into my test environment. So when things were broken, they lost 20 minutes of deciding that it was horribly broken and then pressing the button to get the older version back there. So they weren't doing tests of the last day's code, but they were diving deeper into some other scenarios they otherwise couldn't cover. Right? They still had productivity. That's a lovely little win. Now, we could step up from self-service and go to automatic. Right? We could say, well, when conditions are right, just do the deployment. We shouldn't need a person to make the decision. Most commonly, this happens early in the test environment. Developer commits a change in the source control. We automatically do a build. Whenever the new build shows up, automatically deploy it to dev test and say, hey, developer, here's your thing. Let's go try it. This could happen later. We could say, hey, whenever QA has certified that some version works on a functional level, let's push it out to performance testing and put it through the ringer there in an automated fashion next. Now, it's very natural if we're going to automatically deploy places to kick off our tests, right? Most of us have at least some ambition of running some automated API tests, maybe automated UI testing, some sort of an end-to-end type test. So if I've automated some tests, why wouldn't I run those immediately when I deploy to a test environment? Right? Pretty clear. I have my deployment automation tool fiddling with a bunch of servers and doing a bunch of work anyway. Let's have it do a web service call out to my testing tool, or command line call, frankly. Say, yep, go run my tests, see if things work. And then that can go out to the audience in the email saying, you have a new version, and here's how it did in the automated tests. Now, if we're going to automatically deploy, and we've already talked about this scenario where I might want to roll back if things are horrendously broken. If all my tests are failing, I could automatically roll back too. So if my deployment fails, if my tests come back badly, then look up the previous version that was in the environment and roll back to that. I tend not to be a big fan of this in production. Tend to want people to have eyeballs on it and make a decision. People, again, are better at problem solving and thinking through delicate situations than machines. But if you're doing something with the goal of testers walk in the morning and have something they can test, this is a pretty reasonable strategy. If we put it all together and we go to the extreme, and this is the extreme, what can we do here? Well, when a change is committed to source control, I build it. I deploy it into an environment. I test it alongside all the other stuff for the system. If my tests are complete, right, I've got amazing code coverage and they cover the corner cases and all of that, I can just deploy this thing straight to production next. I got a rollback in case anything goes wrong. Maybe one of my quote-unquote tests in production is I watch how much revenue per minute we're making on the servers with each version. And if revenue per minute goes down after I deploy, I roll it back. This is not for most people. And I think in any sort of a regulated environment, it probably blows up all your separation of duties rules and things like that. So you're probably not going to go this far. But I bring it up for two reasons. The first is that it's super cool. The second is that the mental exercise of trying to figure out why can't I do this in my environment? Right, setting aside regulation. Right, what prevents me from doing this is almost always a healthy one. Right, because it almost always exposes just how bad our testing is and how much more testing we would need in order to have this kind of confidence. It exposes where we don't have faith in our deployment processes. It exposes a lot of approval processes that we have. And then we can ask, well, why do I have all of these approvals? What does that tell me about how weak our other systems in place and protections are? So I like using this as a benchmark for any organization. See how far they are from being able to turn this on. And for most of us, it's both undesirable and we're far from it. And that's totally okay. But I like it as a mental model. Cool. So in the summary, as we start moving towards Q&A, manual deployments are awful. And they're awful because they assume that people are consistent like machines, and people are pretty bad at being machines. Computers, on the other hand, are pretty good at being machines. They're pretty consistent. And automated deployments let us start doing some really cool stuff, right? As we start thinking about automated rollbacks, as we start thinking about wiring in our test results, as we flesh out this continuous delivery pipeline with faster feedback and freeing up people from being blocked by each other to really just go get their jobs done. Really exciting stuff for me. So that's the summary. This is a really good time to pop into that question tab and throw some questions at us. I would highlight that, hey, we're IBM. We have tools for everything. We certainly have tools in this space. So a couple I would highlight here. We've got UrbanCode Deploy, which honestly, as I laid out, hey, here's all the stuff that you need in a deployment system. That's the kind of thinking we went through when we built this tool, right? Consistent processes, wonderful environment modeling, everything is versioned and auditable, and the architecture scales. So this is the thing that we've been working on the last 10 years. It's pretty sweet. All right. There's a new kind of offering associated with UrbanCode Deploy called UrbanCode Deploy with Patterns. This is basically letting me have environments on demand. So it sits on top of a cloud layer like Amazon Web Services, OpenStack, or VMware vCenter, and it exposes a lot of the infrastructure stuff, compute, network, and storage, and lets you design a model environment and map the parts of your application to it. And it gives you a button that you can press, and it calls out to the cloud and says, give me this stuff and wire yourself together this way with the network, and then give me all of those servers to deploy to. And then the deployment tool can deploy to them. And you can live with this environment and change it over time to make incremental change rather than throw the whole thing out. Pretty slick. And then finally, UrbanCode Release. If your spreadsheet, right, that says here's how we're going to deal with our release weekend, if that would survive and still have a lot of stuff in it after you automated the deployments of each application, because you also need to orchestrate how the deployment of application A needs to go out relative to application B, relative to application C. UrbanCode Release goes up that additional level and talks about orchestration of multi-application delivery pipelines, multi-application release events. How do I handle my big quarterly release? How do I handle weekly releases of 4 apps? All that stuff. So there's that. And that brings to a close the crass commercialism portion of the webinar. A couple more resources I'd point you at. 2 good books, DevOps for Dummies and the Application Release and Deployment for Dummies. Out on DeveloperWorks, there's a lot of great DevOps content that I also recommend. And with that, I'd like to turn it back over to Cesar to kind of grab the questions that you guys are putting into the Q&A panel and share with me that, what those questions are, and we'll take these for a while. Thank you, everybody.
Thanks, Eric. We have a question here. Can you clarify the difference between UrbanCode, deploy, and release?
Yeah. So deploy's fundamental goal is to give you a button that you press and the whole application is deployed out to the environment. So that you've got these multi-tier application, and it orchestrates the change across that. Release orchestrates the change across many of those applications. Now, there's also kind of the release management aspect of all of this. Maybe I do want approvals on each environment. Maybe I want to automatically check quality statuses or automatically deploy if applications meet quality statuses. And that's a situation where kind of a base set of that capability is included in deploy, but it's fleshed out much nicer in release as well. So hopefully that makes sense. Shoot me another question if it doesn't. But that's generally the distinction between the two. And obviously they're complementary in that if we're orchestrating changes across applications in release, and part of that is running an automated deployment, release calls deploy and says run that deployment. So they integrate. All right, so what's our next question?
Okay, so there's a good one here. What is DevOps and how does it relate to automated deployment and CI?
And continuous integration, yeah. So DevOps is a cultural movement or a mindset towards approaching a set of problems in business and IT more specifically, and based on the fundamental observation that we have organized ourselves into a bunch of discrete silos, developers here, testers here, ops here, and we get a lot of ugly inefficiencies out of that, right? We tell our developers make features, and we tell our ops guys make sure the applications run, and this is what they internalize as what's valuable. And developers stop caring that much about whether their code actually runs, and the ops people don't care all that much about releasing change. It's only a risk towards keeping things running, and so they fight, and they end up creating processes for each other that are inefficient. So what DevOps says is we need to reorient how we're working to be considerably more collaborative across these traditional silos, because the pace of change that is required in modern business is too fast for these slow processes, for there to be all of this friction within our orgs. So we need to build a more collaborative culture. We probably need to automate a bunch of stuff. We're going to have a bias towards measuring everything. And we're going to have a lot of shared responsibility. Developers are going to take responsibility to respond to outages. It's their problem if the software is not running in production. Operations is going to take responsibility for trying to help developers make changes faster. And so we're going to need to kind of take this approach while simultaneously not losing our safeguards and our separation of duties and our drive for quality. So that's kind of the long form answer. If you just search IBM DevOps, I'm sure we've got I know we have a very formal definition, but that's the big picture. How does this then intersect? Some of the implications are that we want the same automated tool to be used by development and operations for things like deployment, and then for continuous integration for things like build. We don't want to have a distinction between the continuous integration build and the release build. That's done by different people. That introduces risk. We've got kind of overhead of maintaining multiple tools. We've got a tendency to not share visibility and not know what each other are doing because we're using different tools. That helps us have more distrust rather than more trust. So it's tricky when we're talking about DevOps. We end up talking about a lot of squishy terms like collaboration and trust and that stuff that sounds like a bunch of hippies, right? But we're talking about actually very practical techniques for working better in the delivery of high-value software that helps our business win in the market. And that's really what it's all about. And we're saying that things like distrust creates overhead and risk. And we need to tackle that very directly. So hopefully that helps. Again, we do whole webinars on this topic as well. And so some of those other links that you see down there, I should probably use being updated. We'll have discussions on, hey, what's DevOps and how do I get started? All right. Do we have any more questions?
Excellent. Yeah, we just have a few more here. What are your thoughts on using tools like Qbot for integrating chat to manage the deployment process?
Integrating tools seems so I'm torn. All right, so I think any tool that helps us collaborate is good. Naturally, on its own, is good. And I certainly think having your automation, post to, chat room, IRC channel, something like that, totally reasonable, totally healthy. Where I pause is, am I talking about adding a tool to help a bunch of people do their manual work better? Well, if it does, then it could be a useful step change, right? A little incremental improvement. But it doesn't get us to the place where we don't have 20 people simultaneously working on a deployment. And I think that's fundamentally what we're shooting for, is to get out of that game. So that's the only place I pause, is we want to get out of the game where we're thinking, well, I want a bridge line open that 40 people are dialed into, and some chat, and this and that, and well, my big document to describe the plan for the day. That's what we want to get away from to the degree that we can. And to the degree that we can't, collaboration tools are beneficial. So hopefully that's fair. All right. Do we have any more? I think I see, actually I see one in the chat that came to me. Can we work with Windows Server 2012? I believe UrbanCode Deploy does formally support Windows 2012, so yes. So hopefully that's a good, quick answer. Do you have any more questions that have come in?
Yes. How do you handle multiple application deployments running concurrently, 2 to 12 at a time?
Yeah, that's fine. And that's actually going to be normal at any enterprise of scale, that you're going to have a lot of activity going on, especially as you transition towards, hey, when a build completes, I'm going to start doing a deployment. As you look at organizations that have thousands of developers, each in a fairly agile way, committing once or twice a day at least, you're going to end up with a lot of deployments happening, and often at the same time. So yeah, that fundamentally that's got to be supported. And then with UrbanCode Deploy in particular, we've invested a lot in kind of a scalable architecture where we can have multiple master servers. The work is done out on agents to make sure the master servers don't get overloaded. So we've got customers supporting the applications dealt with by thousands of developers going out to thousands of machines, and so yeah, you end up with a lot of concurrency. And that's the fun part. That's where we start saying, yeah, no, I can't try to take my continuous integration tool and bend it to that purpose. All right.
Great. I think we have one last question here.
Sure.
How does UrbanCode differ from what open source automation tools like Jenkins or Hudson provide?
So yeah, and I'll answer the corollary as well, which is what about Chef and Puppet? So when you look at something like Jenkins, it's fundamentally a build tool. Now, with any automation tool, a smart engineer can kind of bend it to a broad set of purposes. The primary way that something like Jenkins has been repurposed towards deployment is with the deployment pipeline plugins. And if you are going to use it for deployments, use one of them. You should. And that gives you some notion of environment and things like that can help. But these deployment pipelines are build pipelines. I take one build and I promote it through my environments. The multi-component aspect of kind of real applications that I've got, a front end and 2 web services and a database or 2 on the back end, starts meaning that deploying a build isn't good enough. You need to deploy several builds and several things that don't get built in a coordinated fashion. And that's really where UrbanCode Deploy shines. It's also been architected from the ground up to be a deployment tool rather than a build tool. And we've written build tools. We know the difference. Right? That has big implications for how you do security, for how you manage servers and targets and environments. There's a lot of fundamental stuff that gets done a little bit differently or very differently to kind of change from a developer-oriented build tool that's designed really to work at a team or department scale to enterprise deployment automation. So that's pretty straightforward. The Puppets and Chefs of the world are designed to work at very large scales. but they tend to operate on the here's what kinds of servers should be. That's their fundamental metaphor. Whereas application changes, again, because we have multiple components, have to be very environment aware, that the kind of server is dev versus QA versus QA4 versus performance test versus production. And that a logical change is going to impact, again, multiple components, multiple tiers, many, many servers that have different roles. And to try to use those tools for that orchestration purpose tends to mean that you're writing a lot of Ruby code, or at least a lot of code, you know, whether that's a specialized chef script, whether using the M collective technology out of Puppet, you're writing code to do that. Whereas in a dedicated deployment automation tool, you're dragging a couple of boxes in a nice GUI and saying, do this stuff first, and then do all of those servers next, and then do group 1 of this kind of server and group 2 of that kind of server. Right? And maybe you're doing some things at the same time. Right? It's really designed for that orchestration and makes that orchestration stupidly easy, rather than making it code that's tricky because it's not really what the tools are built for. So I think all of these tools are good. When you're looking at a DevOps pipeline or a continuous delivery tool chain, I think you should have a build server. Monitoring source control, and Jenkins is a pretty good one. We offer some of our own. Jenkins is pretty good though. And then that should hand off builds to your deployment tool. And that should be deploying to environments. Those environments might be kept compliant with your patching rules, with your security rules, with things like that, by a tool like Chef or Puppet. They do a fantastic job of taking a new virtual machine and making it a useful box. Good use for them. So you'll have a tool chain, and all of these tools have roles to play within that tool chain, but they tend to be more complementary than competitive. So with that, one last one. Which do you prefer, Chef, Puppet, Ansible, or Salt? I am actually not opinionated on this. I haven't gone deep enough on these to have a horse in that race. People I know tend to prefer Chef, but meh. Don't take my word for it. Go do your own research on that one. So I want to thank everybody for hanging with me, for the wonderful questions, and I truly hope that this was a valuable session. The slides for this are up at slideshare.net/UrbanCode. You'll also find a bunch of other good slides there. Thank you very, very much.
Thank you very much for joining, and be on the lookout for future webcasts on the website. Thank you very much again. Thanks, Eric. Great presentation.